So now we'll get to how to compute section properties. There's a few prerequisites before you can run that computation. You've got to make sure the section is well formed. That is, there are no floating branches, meaning every branch is connected to the section. And there's a material defined for each branch. It doesn't have to be the same material, but each branch has to have a material. So here we have a simple section, and a couple of things that might be useful is to, if you right-click on a branch and say select branches connected to this branch, everything should highlight. Another thing that's useful is if you click on a junction and say select branches connected to this junction, you should see all the branches that you expect to see highlighted. Okay, now let's apply a material. I'll just apply a material to all of them. And now we're ready to do the computation, which is found underneath the Computations tab, and click Compute. When that's done, you'll see these three green dots. P is the plastic centroid, which is to say that the area above and below that point are equal, and the area of the section to the right and left are equal. The elastic centroid, which takes into account the material properties, and the shear center. So over here, you can go to the Section Properties tab and up pop Section Properties. You'll see it's broken up into elastic and plastic. Let's go to look at the elastic first. And you see the headers. It gives a grouping, a symbol, the actual value, units, and a description of what that property is. So if we'll run down through these quickly, the area of the section, both elastic and geometric. Also, if you've defined a density for the material, you'll see a weight here of the section. The number of cells, and there's 3 in that section. The principal angle, the location of the centroid, moments of inertia about the centroid, product of inertia, polar moment of inertia, and the moments of inertia about the global x and y, which is the origin axis system. Your max and min, second moment of inertia, and your radius of gyrations about the centroid, polar radius of gyration, min and max radius of gyration. The shear center, as we talked about before, there's 2 different methods for doing complex calculations, the Johnson method and the Alfano method, and they show the results for both. Same for torsional constant, the results for Johnson and your torsional stiffness, and Alfano. Your section modulus, max and min about the centroidal x, max and min about the centroidal y, max and min about the principal x, and max and min about the principal y. Your shear areas about the centroidal and the principal axes. And then your warping constant, which is again done by 2 different methods, the Johnson and Alfano, and this shows the results for both. This is the contour warping. There's also a calculation for thickness warping, which is the warping traversely across the branch, and then the sum of those 2, which is the total warping constant, and Johnson and Alfano. Over here are the elastic properties. You have your section modulus, about centroidal x and principal x and y, the area bisection centroid, your shear area, the area of bisection is this point here, your shear area, moment capacity, modulus ratios. Printing results. If you go to the File menu here and look at Print, here's Print Preview, which I'll just show you, walk through quickly. You give a title for the section, your company name, who prepared it. These fields are simply in the title block and you can use them for whatever you want. Down here is your print options. Construction info is the parameters given for the branches when they were built, and also so you turn that and click on materials. You should see those in the output. So here's the section that shows when it was created, that it was ThinWallSection, and the version, the file that this section was saved as, your plastic section properties, elastic section properties, the branches, what the X and Y locations are, and the material that was used for each branch, and the material properties for aluminum. So once you've done the section properties calculation, you can then plot some of the geometric results that were computed. So here's our section, and we've done the section properties calculations. You'll then see that the geometric results pull down becomes active. And it gives you a list of functions for plotting the contour warping values, the first elastic moments, Sx, Sy, and the sectorial area moment, Sw. And these three functions are called the distribution functions because they control the distribution of shears on the section. And then there's plots of normalized horizontal and vertical shear. So if we select a function to plot, you'll see the plot over the section. Red is positive, blue is negative. You'll see values at each junction point for that particular plot. You'll also see these arrows which indicate the direction of parameterization of a branch. So there's one arrow on each branch, and it's located at the centroid. This evaluator appears, and it shows you what function is currently plotted, the location of the cursor on the section, and the cursor location is controlled by this slide bar, which moves the section, the cursor point over the section, showing the current results. You can at any time, if you'd like, within the current branch, if you give a coordinate location, it will hop to that point. You can go to the most positive location, hop down here, or the most negative. You can, if you're moving along over the section, you can say, save the current location, and then it will remember that point. Deleting clears any points that you've saved. The running load calculations, we'll talk about those later. If we go down here and let's plot the vertical shear on the section. And here you'll see for shear values, positive means that the shear is in the same direction as the parameterization. So on this section, it's going vertically. Whereas it's negative on this section because the shear is going opposite of the parameterization. It's going up on both of these branches. So on this branch, the shear is going this way. However, on this branch, the shear is going the opposite direction. So these distribution functions are very useful if you're going into the detailed understanding of the section. And I think that about covers the evaluation plots.